Okay, today in class you're going to be working on the Rotational Equilibrium Lab, and you're going to be plotting the force needed to maintain equilibrium versus the distance from the fulcrum. I don't think you're going to have any part of that, any problem with that part. However, for the second part, when you have to do the force needed to maintain equilibrium and the angle, that might be a little bit more challenging because it's going to be something you've never seen before. So let me show you how you're going to do that. Okay, so for me, my constants when I did the lab were, let's see, my weight was a constant weight, and that was equal to, I think it was, let's see if I remember right, I'll have to write it down here, 5 newtons. And that was at at distance equal to 0.45 meters from the fulcrum. And the only other constant I had was for where I applied my force for the spring scale. So d spring scale distance from fulcrum, and that was equal to 0.400 meters. Okay, so for this, my angle, so let's see, insert symbol theta in degrees. I did the following angles: 45, 50, 55, 65, 70, 75, 85, 90, 95, 105, 110, 115, 125, 130, and 135. So I have 15 data points. And the forces that I had from the spring scale were 9.25, 7.5, 7, 6.25, 6, 5.75, 5.6, 5.6, I couldn't see any difference, 5.6, 5.75, 6, 6.25, 7, 7.25, and 8.5. Okay, so now I want to do a scatter plot, and I right click on this, select the data, and for the x's it's going to be my angles, and for the y's it's going to be my forces. What happened here? Oops, I messed something up here. This is 9.25. There we go, much better. Now I really should put in titles and stuff for this, so let's see here. Actually, something like that. And I can click on those, delete those, put this in here, lines. And this was force versus angle. And this was the force. And this was the angle. Okay, so my point here though was not to do all that stuff, but to notice this is some kind of relationship I've never seen before. I don't have any idea how to do that. But you might guess that maybe this has to do some kind of trig function, because it looks like it has a maximum force at 0 degrees, and a minimum force, or excuse me, another maximum force maybe at 180 degrees, and a minimum at looks like around 90. So maybe I need to do some kind of trig function in here, and our first guess might be maybe to do a cosine. I'm going to insert actually insert column here. So maybe it's cosine. I mean, I don't know, I'm just totally guessing here. But what I want you to see is that when you do trig functions in Excel, they're actually for radian angles, not for degree angles. So at 90 degrees, that should be 0, right? So what I need to do before I do this is I need to change all these angles into radians. So insert, right. So change it into radians. So how do I do that? I go and multiply it by pi, this angle, excuse me, this angle here, oh, I messed up, pi times this angle divided by 180. And now, when I look at this, it's going to be, I don't want A5, I want B5. And now I can copy and paste this. So now notice at 90 degrees, I'm going to get something pretty much 0 there. Okay. So now I'm going to change this so that my x values, instead of being degrees, and in fact I can go ahead and change it to radians and see what happens. Notice for radians it doesn't do anything. It looks exactly the same. I'm actually going to change it to cosine of theta. Well, that didn't really change anything either. So maybe it's not cosine, maybe it's some other trig function. So let's see, I'm going to hit cancel here. Cancel. So it must not be cosine. Let's try something else, like maybe sine. And again, this is not going to be in degrees anymore, it's radians, so I'm going to get rid of that. So this is going to be sine instead. Okay, then I'm going to change this, select the data, edit it, and the x values, instead of being the degrees or the radians, which we know gives us the same strange relationship, I want to try sine of the angle. And then hit OK. Now I know that you might be thinking, well, that doesn't do any good either. That's some kind of weird thing. But actually, this should look familiar. This should look like something that we can linearize now. Okay, at this point. So I'm going to kind of leave it at that and let you figure out. Right now what I have here plotted is sine, and of course this was in radians, but now since I sine, I don't have any degrees or anything. This is sine. So while this is not really what I want, this is not my linearized graph, it's a lot better than what it was before, and now I can linearize it.